Hey everyone, we're going to walk through all of the Pear Deck problems so that you have seen each type of problem solved. All right, so this first one is that first problem on the Pear Deck, which is a dropping problem, right? You're taking a selfie on top of Willis Tower, you drop your phone, and you sit there and watch it plummet all the way to the ground. And then let's calculate some things, all right? So we have our equations that we can use, always here and present. We have our table that we're always going to have available and fill out. So this is a dropping problem. All right, there's certain things we know about dropping problems. Right off the bat, we know that there's nothing in the x direction, so we can eliminate that right up front. Next, we know that it was going from not moving to moving, so our initial velocity is always going to be 0 meters per second. The next thing we know is the y direction, our acceleration will always be negative 10 meters per second squared. So these are things that no matter what else the problem tells you, if it is a dropping problem, these things are true. All right, next we go to the problem and see what information we have in there that we can then add to our table and then begin to solve some things. So it says if we dropped it and the person happened to notice that the height of the Willis Tower is 442 meters. And since we're talking about the change in position of that phone, it dropped 442 meters below us. We have to put it as negative 442. All right, so right now we have three values, which for pretty much all of our equations, we need at least three different values to solve. And so we can begin to answer some of the questions, right? How long does it take to hit the ground? And how fast is it going right before it hits the ground? All right, so let's take a look at time. Time tends to be a really important variable to find early on because it kind of unlocks some of the other values. So let's see if we can solve for it first. Always the first thing to do is look for the equation that has t in it. So that is these top three. All right, so let's see if any one of them works for us. Right, this one we need a acceleration, which we do have. We need initial and final velocity. We don't have the final, and we don't have t. So we have two variables. We can't use this. Final velocity and t again. We can't use this one either. These are really just derivatives of each other. Now we have our change in x, how far it fell. We have our initial velocity. We don't have time. 1/2, and we have this. All right. Again, another key is remembering we should never have a quadratic. If we do, then there's another route that we need to go because we're not going to solve any using quadratics. So in this case, all right, I go ahead and I rewrite my equation, and then I plug the numbers in. So this is negative 442. My initial velocity is 0t, so that's going to be eliminated, plus 1/2, oops, sorry, 1/2 negative 10 times t squared. All right, since this is eliminated, we just have the t squared. This is not a quadratic. We can use this. 1/2 of negative 10 is negative 5, so we're going to divide by negative 5 on both sides. Eliminate those. The negatives get eliminated, which here's the key. If you get a negative time, it's because you forgot a sign somewhere. Usually it's in the displacement on these dropping problems. So make sure you check to have that. All right, so now we have this becomes 88.4 equals t squared. I take the square root of each side. My time value is 9.4 seconds. It's positive as it should be. And so it took 9.4 seconds for that phone to fall. All right, so now I can take that information and help me to solve the final velocity. So now this equation, and a lot of times you're going to use these two in most of your problems. Not always. Sometimes we need to use this one to find final velocity. But for the most part, these are the main ones we're going to use. Where people get hung up is that they use the wrong values in here. All right, so let's make sure that we are only using one part at a time, either the y direction or the x direction. We cannot use numbers from both sides. The only time that's the case is t, because it is actually consistent for the x direction and the y direction. Otherwise, everything else, there's values for the x and the y that are different. All right, so let's find that final velocity. All right, my final velocity, I don't know because that's what I'm solving for. My initial is 0. Negative 10 is my acceleration, and we just discovered that it was in the air for 9.4 seconds. My final velocity is a negative 94 meters per second. negative 94 meters per second squared. And just meters, make sure we have the right units in our answers. That is important. So now we have everything filled in for this dropping problem. It's going to be a consistent approach for most every dropping problem that we just showed you. All right, so the big thing you notice, since everything's traveling downward, most everything is going to be negative. Your time cannot be negative. So keep those things in mind. This is that first paired deck problem and a dropping problem that you could use to help you solve other types.